What we found is that harp seals have always eaten more fish than harvested by fisheries, even before the cod fishery collapsed. So our estimates were that harp seals were eating about 1.5 times more fish than fisheries were harvesting in the mid-80s. And then if we look after the cod fishery collapsed and then the moratorium era, fisheries were actually very reduced. There wasn't much happening in terms of the volume of fisheries that were fish being harvested. So if we compare that to how much harp seals were eating in the system, we found that harp seals were eating 20 times more in terms of weight or volume than the fisheries were harvesting. A lot of the information that we used, we were sort of synthesizing from work that DFO has done. But what we did that was different was we put it all together in a numerical model that represents the food web. And so then once we have this model and it tracks energy all the way from the smallest phytoplankton all the way to capelin, to cod and to harp seals, then this allows us to come up with a system-wide estimate of what harp seals are eating. We didn't just look at stomach contents. There's a couple of other techniques called fatty acid analysis or stable isotope analysis that use muscle tissue and then try to figure out what a harp seal's diet is using that technique. And so the idea was to use as many different approaches as possible in order to try to see if they tell a consistent story. What I think our study shows that they are a significant source of mortality on northern cod, and that it would be a more kind of comprehensive modeling approach if we did include them in the stock assessment models. If we reduced harp seals by 25%, it would lead to a 3% increase in cod on the Newfoundland and Labrador shelf, or an 8% increase in cod on the Grand Banks.